The centerpiece of FCAS is the Next Generation Fighter, a sixth-generation aircraft designed with advanced stealth capabilities, superior sensor fusion, and unmatched connectivity. However, the real innovation lies in how this fighter interacts with its surrounding drone swarm. The development timeline for FCAS aims to deliver operational capabilities by the early 2030s, with key technologies being tested between 2027 and 2030. These years are critical as Europe positions itself alongside global competitors like the United States NGAD program and the United Kingdom's Tempest initiative. The rise of FCAS represents a shift in strategy. Instead of relying on individual aircraft performance, Europe is investing in a distributed network of systems capable of overwhelming any adversary through coordination and intelligence. This approach marks the beginning of a new era in air combat, one where numbers, data, and AI-driven decisions matter more than ever before. The dawn of FCAS, Europe's vision for future air combat. In the evolving theater of modern warfare, air superiority is no longer defined by a single aircraft dominating the skies. Instead, it is determined by networks, intelligence, and coordination across multiple platforms. At the center of this transformation stands Europe's most ambitious military aviation project, the Future Combat Air System, or FCAS. Developed primarily by France, Germany, and Spain, FCAS is not just a fighter jet program. It is a revolutionary combat ecosystem designed to redefine how wars are fought in the air between 2027 and 2030 and beyond. At its core lies the concept of a system of systems, where manned aircraft, unmanned drones, satellites, and digital networks operate seamlessly together. Unlike traditional fighter programs, FCAS is built around the idea that the pilot is no longer alone in combat. Instead, they are supported by a swarm of intelligent drones known as remote carriers. These drones act as extensions of the main aircraft, performing tasks such as reconnaissance, electronic warfare, and direct combat operations. Engineering the swarm, remote carriers, and autonomous warfare. The concept of drone swarms is not entirely new, but FCAS takes it to an unprecedented level. At the heart of this system are remote carriers, autonomous drones designed to operate in coordination with the next generation fighter. These drones vary in size and capability. Some are small, expendable units used for reconnaissance or as decoys, while others are larger platforms capable of carrying weapons and engaging enemy targets directly. Together, they form a layered swarm, capable of adapting to different combat scenarios. Each drone is equipped with advanced sensors, communication systems, and AI algorithms that allow it to operate independently while still remaining connected to the overall network. This combination of autonomy and coordination is what makes the swarm so powerful. In terms of technical capabilities, remote carriers are expected to feature stealth designs, high-speed propulsion systems, and modular payload configurations. This allows them to be customized for specific missions, whether it's electronic warfare, surveillance, or direct attack. One of the key advantages of drone swarms is their ability to overwhelm enemy defenses. Traditional air defense systems are designed to track and engage a limited number of targets. A coordinated swarm of drones can saturate these systems, creating opportunities for the main aircraft to strike. The integration of these drones with the next generation fighter is made possible through secure data links and advanced communication networks. These links allow the pilot or the onboard AI to control and coordinate the swarm in real time. This level of integration represents a major step forward in military technology. It transforms the fighter jet from a standalone platform into the command center of a distributed combat network.